Okay, so we're reviewing test number 3. This is from fall 2017. We'll tackle the multiple choice questions first, and then we'll get on to the free response. So, number 1, a researcher is attempting to determine if there's a correlation between upbringing and the committing of sex crimes as an adult. Which of the following designs is the most appropriate for this observational study? Obtain a simple random sample of 4-year-old children and follow their development up until the age of 18. Obtain police records at ages 25 through 65 every 10 years until death to determine the number of sex crimes committed and analyze. All right, so that's just, it looks like observation over a period of time. Obtain a stratified random sample of 4-year-old children, strata determined by race, and follow their upbringing. It looks like pretty much everything else is the same. So it's a question of, do we want a simple random sample or do we want to break it down by race? All right. Well, I guess it all depends on in what capacity upbringing is represented. Not being an expert on it, there is a possibility that if we do a simple random sample, that we could get, let's say 100 people, a simple random sample, they could all be white people from northern Westchester. All right. So, like in terms of the outcomes, I don't know what to expect. It could all be individuals who are, I'm just trying to think of a reasonable thing, like great at math. I don't know, terrible in English, or, like some common thread among all the individuals. But if you break it up based off of some kind of strata, not even necessarily by race, but just by guaranteeing that individuals from different backgrounds would be involved in the study, you might get more accurate results. Right. So with that in mind, I would say that B is probably better than A. I don't know if it's the best yet. Voluntary response, that one, no. Voluntary response sample. I don't know too many people who are going to participate in a study and say, hey, yeah, I committed one. I'd like to be part of your study. Obtain a simple random sample of 4-year-old children and follow their development up until the age of 18. Observe each individual as they live their daily lives, making certain to take special note of the committing of sex crimes. That just sounds absurd. Especially to take special note of the committing of sex crimes. I'd like to think that if I were the one conducting the study, that the sex crime would never happen if I were there, because stop it, So, so I'm going to go with B on this. For number 2, so we start off with a nice controversial one, but after that they should get a little bit more straightforward. Study is conducted to determine if type of music listened to has any effect on math test scores. 4 math classes are selected at random and given a test on basic math concepts. Student scores are recorded and analyzed using statistical graphs. The fact that they're comparative box plots doesn't really matter. A different type of music is played in each class: rock, rap, and country. So I guess we could assume that the 4th class is getting nothing. That would be the control. Which of the following is most appropriate? There is 1 explanatory variable and 3 response variables. I'll just I'm going to stop you right there. So 1 explanatory variable, 1 response variable. That's what we're looking for. That's a controlled experiment. So 1 explanatory, 3 response? Nope. 3 explanatory variables? Nope. 3 explanatory variables? Nope. 3 levels of a single explanatory variable. All right. The explanatory variable is type of music. And the 3 levels would be rock, rap, and country. You generally don't consider the control as being a level. All right. The response variable, which they didn't really, like in this particular choice, doesn't really factor in, would be scores on the assessment. Which of the following are important in the designs of experiment? Control of confounding variables. Well, confounding variables are bad, so let's control those, sure. Replication in assigning subjects to different treatments. I'm sorry, randomization in assigning subjects to treatments. Replication of the experiment using a sufficient number of subjects. Yeah, control, randomization, replication. Those are the three ingredients in a good experiment. So 1, 2, and 3 is what we want. Which of the following are true about the design of match pair experiments? Each subject might receive both treatments. Well, both treatments. There should only be one treatment. So that's out. Each pair of subjects receives the identical treatment and differences in their responses are noted. Well, no, because that is independent samples. Blocking is one form of a match pair design. Well, yeah, and we're going to go with that one. So 3 only. And not just because we've eliminated this one, this one, this one, and this one, and it's the only one left, which is, a good test-taking strategy. But in terms of understanding, blocking is when you group, so blocking, grouping similar individuals. All right. So when you're blocking individuals, you're blocking them based on some kind of similarity. So if I wanted to test left-handed and right-handed dexterity, like I may want to do it by having all of my lefties, complete some sort of task with their left hand and then complete the same task with their right hand and then take the difference between completion time or number of completed tasks or whatever. Right? So that's a similarity. They're all lefties. Right? Another similarity would be that they're all completing something with both hands. So in either way, I mean, it's kind of a flimsy definition. It's kind of like saying, like the real number system is an integer. I'll even go, is a fraction a real number? Well, a fraction is a rational number, and a rational number is a real number, so therefore a fraction is a real number. So it's kind of like a few levels removed from being part of the textbook definition of a real number, but it's in there, right? And that's what we're looking at here. Number 5, a nutritionist believes that having each player take a vitamin pill before a game enhances the performance of the football team. So just to be clear, it seems that the nutritionist believes that just that vitamin pill, that magic vitamin pill, before a game is going to enhance the performance of the football team. Right? And we don't know what enhance means. Although that word enhance tends to set off alarm bells. During the course of one season, each player takes a vitamin, quote unquote, vitamin pill before each game, and the team achieves a winning season for the first time in several years. Is this an experiment or an observational study? Now, it'd be lovely if it was just yes or no, because it is an experiment. It's just not a good one, because there's so many other variables. Another variable would be, was there a coaching change? Another variable would be, were the players the same from one year to another? Right? Another variable would be, what's the level of competition? Right? So all these different things are in play. So we would conclude choice A, because it's an experiment, just not a good one. Number 6, a town has one high school which buses students from urban, suburban, and rural communities. Which of the following samples is recommended in studying attitudes toward tracking of students in honors, regular, and below grade classes? Convenience sample. I wouldn't recommend the convenience sample. Simple random sample. Well, if I do a simple random sample, it's possible that every single individual could be from the rural community. So, nope. Stratified is the answer because that will guarantee that each member or each category would be represented. All right. So that's the winner. Systematic sample would be like lining up all the students and having them count off 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All the ones come together, all the twos come together, all the threes come together, all the fours come together, all the fives come together. It's possible that, that they could break down into like all the ones are from the urban community, all the twos are from suburban, but the likelihood is not very good. So systematic is out, voluntary response, like it's just never a good idea. Company has 1,000 employees evenly distributed throughout 5 assembly plants. A sample of 30 employees is to be chosen as follows. Each of the 5 managers will be asked to place the 200 time cards of their respective employees in a bag, shake them up, and randomly draw out 6 names. 6 names from each plant will be put together to make up the sample. Will this method result in a simple random sample of the 1,000 employees? So the answer is no, because it's going to be stratified. Once you break them up into groups, stratified is a likely outcome. All right, so boom, shaka laka. Now, no, because the plants are randomly chosen. Well, no, because they're all included. So it has to be E. And it says no, because not every group of 30 employees has the same chance of being selected. It's kind of a weird sentence, but what it's telling us is that with a simple random sample, it's possible that all 30 come from the same plant. It's possible that maybe you have 10 from plant A, 10 from plant B, 10 from plant C, and then 0 from plant D and 0 from plant E. I'll throw an or in there. Or maybe it's 15 from A, 15 from B, and 0 for C, D, or E. Now for stratified, go red for those keeping score at home. Guaranteed. They're going to place the 200 time cards of their respective employees and then into a bag and shake them out and randomly draw out 6 names. So it's guaranteed that 6 are coming from A, from plant A, 6 from B, 6 from C, 6 from D, and 6 from E. So all those different possibilities for a simple random sample, only one possible way in which it could play out. Now, it's not guaranteed it's going to be a particular set of 6 outcomes. It could be any 6 of the 200 time cards, but it's still going to be 6 from each plant. That's what makes it stratified. 8, in the study of the effect of music on worker productivity, employees were told that a different genre of background music would be played each day in the corresponding production outputs noted. Every change in music resulted in an increase in production. All right, so they were told. So anytime you know that you're part of a study and that impacts your behavior, that's an example of what we call the Hawthorne effect. All right. In one study on the effect of eating meat products, that eating meat products had on weight level, a simple random sample of 500 subjects who admitted to eating meat admitted. All right. So they weren't given meat. They were just saying that they eat meat at least once a day. How their weights compared with those of an independent simple random sample of 500 people who claimed to be vegetarians. All right, so claimed. We don't know this for a fact. We're just assuming. In a second study, an SRS of 500 subjects were served. You got served. At least one meat meal per day for 6 months, while an independent, that's very healthy, an independent simple random sample of 500 others were chosen to receive a strictly vegetarian diet for 6 months with weights compared after 6 months. So we're talking about two different groups of individuals. The first one could not possibly be an experiment because no treatment was imposed. So boom, boom. And E doesn't make sense. You can't have something that's part experiment, part observational study. It's one or the other. All right. The second one is actually an experiment because a treatment was imposed. Right? Individuals were given or chosen to receive. So that makes B the correct answer. Number 10, the null and alternative hypotheses divide all possibilities into two non-overlapping sets. In statistical analysis, the burden of proof traditionally lies with the alternative hypothesis because the null hypothesis is your status quo. That's the incumbent. That's the king or queen that you're trying to dethrone. Right? The alternative is the challenger. All right. So then